In this lecture, we will discuss the introduction to Q. Hello everyone. We have been talking about data structures for some time now. As we know, data structures are used to store and organize data in computers. In this series, we have discussed certain data structures like arrays, linked lists, and stack. In this lesson, we are going to introduce you to queues. We are going to talk about QADT just like the way we did for stack. And first we are going to talk about Q as an abstract data type, or ADT. As we know, when we talk about an abstract data type, we define only the features and operations of the data structure and do not go into the implementation details. We will only talk about the data structure in a logical view. Okay, so let's get started. Q data structure is exactly what we mean when we say Q in the real world. Q is a structure in which whatever goes in first comes out first. Earlier, when we said stack, which is last in, first out structure, in Q, however, insertion must happen from one end. We call rear or tail of the queue, and any removal must happen from the other end that we call front or head of the queue. If I have to define Q formally as an abstract data type, then Q is a list or collection with the restriction that insertion can be performed at one end that we call rear of Q, and deletion can be performed at the other end that we call front or head of Q. Now let's define the interface or operations that are available with Q. Just like stack, there are two fundamental operations here. An insertion is called NQ operation. NQ should insert an element at the rear or tail end of the queue. A deletion is called DQ operation. DQ should remove an element from the front or head of the queue, and DQ often returns the element. The signatures for NQ and DQ for a queue of integers might look something like this. NQ is returning void here, while DQ is returning an integer. This integer should be removed from the queue. You can design DQ to return void. Typically, the third operation, front, is kept just to look at the head element, just like top operation we had in stack. Okay, we can have another operation. We can have an operation to check whether the queue is empty or not. Okay, so these are the operations I have defined for a QADT. NQ, DQ, front, and is empty. We can insert one element at a time from the queue using NQ and DQ. Front is only to look at the element at the head, and is empty is only used to determine whether the queue is full or empty. All of these operations I have written here must take constant time, or in other words, a time complexity big O of 1. Logically, a queue is shown as a container, open on two sides. So an element can be inserted or NQ'd from one side, and an element can be removed or DQ'd from the other side. Let's say initially we have an empty queue. I'll first write down the operation and then show you in logical view. Let's say I want to NQ number 2. Right now, this figure that I'm showing as an empty queue of integers. And I'm saying that I'm performing an NQ operation here. In a program, I would be calling the enqueue function and passing the number 2 as an argument. After this enqueue, we have only one element in the queue, and we have one integer in the queue. Because we have only one element in the queue, front and rear of the queue are the same. Let's enqueue one more integer. Now I'm going to insert number 5. 5 will be inserted at the rear of the queue. Let's enqueue one more. Now I want to call the dequeue operation. So we'll pick up 2 from the head and it will go out. Enqueue and dequeue are fundamental operations available with queue. In our design, we can have some more for our convenience, like front and isEmpty here. I'll call front at this stage and we'll get number 5 as a return. No integer will be removed from the queue. Calling isEmpty at this point can return us a Boolean false. So this is pretty much how queue works. Now, one obvious question can be, what are the real scenarios that we can use queue? What are the use cases of queue? Queue is most often used in a scenario where there is a shared resource that is supposed to serve some requests, but the resource can handle only one request at a time. Let's say we have a printer shared in a network. Any machine on the network can send print requests to the printer. Printer can only serve one request at a time and print only one document at a time. So if a request comes when it's busy, it can't be like, "I'm busy, send your request later." That would be really rude of the printer. What really happens is that the program that manages the printer puts a request in a queue. As long as there is something in the queue, the printer keeps picking up requests at the front of the queue and serves it. Queues in general are used to simulate wait in a number of scenarios. This is good for an introduction. Until next time, see you.